So and non-rigid connectors. Rigid connectors can be again as well as cast connector, soldered connector and rope connector, whereas non-rigid connectors are different types of non-rigid connectors include dovetail connector, split pontic connector and cross pin-and-main connector. Coming to the rigid connectors. Rigid connections are usually made in metal are usually made by any of these techniques, that is casting, soldering, welding, laser sintering and milling. Out of this, casting is the most commonly used method, where it is cast along with the wax pattern itself. Soldering is a method in which a metal of lower melting point than the parent metal is introduced in between, whereas in welding the intermediate metal used, sometimes the metal is not used, only the common parts are melted, otherwise the introduced metal is of the of melting point same as that of the parent metal. Then laser sintering and milling, these are included in the CAD-CAM. It is a type of these are methods used along with CAD-CAM. Okay. Then coming to cast connectors, it is the most commonly used. Cast connectors these are cast along with like it is waxed on the definitive cast along with the wax pattern, and then the whole FPD will be cast at one go. Thus we will get a strong connector in between connector, and we could shape the connector while waxing up. And the advantage of cast connector is that it is convenient and it has a minimal number of laboratory steps, and it is stronger than soldered connector. Whereas the problem is that if the pattern complexity, that is if it is a long span FPD, it is difficult to handle because the wax pattern can distort when we remove from the die, and also inaccuracy can result in a long span FPD. So in such cases, the preferred method is soldering. That is, in this method, we use an intermediate metal alloy whose melting temperature is lower than that of the parent metal, and the parts being joined is not melted during soldering. In this, first of all, the wax pattern is made and sectioned with a thin ribbon saw, such that when the components are cast, the surface to be joined are flat and parallel and a controlled distance apart, about 0.25 mm. Then after casting the individual components, non-rigid contact, and this helps in distribution of forces when the masticative forces are acting. The pile abutment will go according to the mesial abutment, whereas the moment of this non-rigid connector will help in the will give a small moment to the terminal abutment. So in such cases we can use a non-rigid connector. Then also in long span SPD, if the FPD is crossing anterior and posterior, then it is necessary to give a non-rigid connector, especially in mandibular arch, because while opening and closing there is torsion happening in the mandibular arch. So in such cases also we may give non-rigid connector in between. Then in periodontally weak abutments, if the distal abutment, any of the abutment is periodontally weak, then it will be feasible to give a non-rigid connector, so that even if there is a break in between the whole fixed fascial denture, so the forces acting will be stress developed in between can be relieved. And also even if the distal abutment, if it is questionable and if it has to be removed after some time, we can remove it without disturbing the other part of the FPD. And also in case of a malaligned abutment, in a malaligned abutment, the abutment long axis will be in different direction. So we cannot give a single path of insertion to the whole FPD. So in such case also we can go for a non-rigid connector. So usually the non-rigid connector is incorporated included by fabricated by an incorporation of prefabricated inserts or using custom milling machine or by use of prefabricated plastic inserts. These plastic patterns may be involved into the wax pattern, or after casting we can custom mill the metal surface and then cast the second part. So in all these methods we can incorporate the non-rigid connector. So in a non-rigid connector, mainly there are two parts: a tenon or a male component is attached to the pond, and the tenon or male component, it is attached to the pontic, whereas a mortise or female component is attached to the is prepared within the contours of the retainer. And usually the mortise or female part is placed in the distal aspect of the first part, whereas this tenon or the male component is attached to the pontic in the distal part of the FPD. The limiting factor for a non-rigid connector include a large part size. If the abutment is having a large part size, it can result in sensitivity, and in such cases we may not indicate this non-rigid connector, and it has limitations in abutments with reduced clinical crown. We should have at least a minimal height for the clinical crown so that we could incorporate this tenon-mortise connector or non-rigid connector. So coming to the types of non-rigid connector, as already told, the Dovetail connector or tenon-mortise connector, this is the most common connector. Then split pontic connector, and it is split pontic connector is mainly used in tilt and abutment cases, and also cross spinning wing connectors. It is also mainly used in tilt and abutment cases. So the most common one is tenon-mortise or Dovetail connectors. It is best suited for relieving stress at the midspan of the long FPDs. The path of insertion of the keyway and key should be made parallel to that of the distal. The keyway is made parallel to that of the distal retainer by using a surveyor. That is, the keyway should be parallel to the distal retainer. That's how we could incorporate abutments with disparate long axis. Then in this first of all we will fabricate the mesial component with the female part, and it is cemented, and then later on the pontic or distal component with the male part is cemented over to that. So first the mesial part is inserted, then again the distal part is cemented. And it is usually incorporated distal to the mesial, the pyre abutment, because usually all the tooth will be having a mesial tendency for mesial movement. So if we are giving it the connection, non-rigid connection is given in the distal surface of the pyre abutment, it will lead to a seating action. Whereas if we are giving it in the mesial surface, it can result in an unseating action of the mesial part of the FPD. So it is always preferred to give the non-rigid connector on the distal aspect of the pyre abutment. Now coming to the split pontic connector, in this the attachment is placed entirely inside the pontic. The non-rigid connector is entirely inside the pontic, and that is why it is called a split pontic connector. It is usually used in tilted abutment cases or abutments with disparate axis. And this first of all, the wax pattern for the anterior retainer with the distal arm attached to it is fabricated, and the under surface of the arm is shaped like the tissue surface of the pontic, and with the arm is fabricated, and later on the pontic with the keyway is fabricated and cemented onto it. Then comes the third type of non-rigid connector. It is a cross pin and wing connector. In this, there are two-piece pontic system, and it allows two segments to be rigidly fixed after the retainers have been cemented on the respective abutments. It is primarily used in abutments with disparate long axes. The path of insertion of each tooth preparation is made parallel to the long axis of the tooth. That is, first of all, the long axis of the tooth are different. So first, the distal part is fabricated. Even though the other two in other two methods, the mesial part was first fabricated. In this type, we will fabricate the distal part of the FPD with a beam is fabricated first, and then later on the pontic, the mesial part with the pontic and this space for this wing to be accommodated is fabricated, and it is placed, and later on a pin of 0.7 mm diameter is inserted through the hole of the pontic as well as the wing part, and it is inserted using a mallet from the buccal to the lingual. Once it is fixed, it will act just like a rigid fixed partial denture. This is done because in cases where the long axis is different, and so we cannot obtain a single path of insertion. Thus, coming to the end of the connectors. To conclude with connectors, we have found out that connectors should be selected according to various situations, and the situations like if it is a normal case or in a short span FPDs, we should select the FPD with cast connector, whereas in cases of long span FPD, we may go for a soldering technique or other non-rigid techniques. And in special cases such as spire abutments, questionable distal abutments, malaligned abutments, in such cases we may go for non-rigid abutments. Especially in spire abutment, we may go for dovetail. In cases of tilted abutment, we may go for split pontic, and in abutments with disparate long axis, we may go for cross pin and wing connector. So we also found out that the size, shape and position of the connector predicts the success of the prosthesis. So while we are diagnosing and fixed partial denture, we should keep in consideration to provide maximum strength, aesthetics and the maintenance of. We should keep in mind the maintenance of oral hygiene also while diagnosis of a connector. We should ideally select the connector according to all these, keeping in consideration all these situations. So thank you for today. Thank you very much. Okay, bye bye.